Welcome, students. Welcome to Newton Gate Success Strategies Academy, where we make your dreams come true. Today, we will discuss about a very important topic of IIT JEE, that is, kinematics. In this video, I will go through the introduction of kinematics. First, let us deal with the word mechanics. Mechanics is a branch of physics which deals with the cause and the effects of motion of a particle, rigid objects and deformable bodies. That is, mechanics is classified under two streams, namely kinematics and dynamics. Here, we are more interested into kinematics. The word kinematics means the science of motion. Branch of mechanics was deal with the study of motion without going into the cause of the motion, that is, torque, force, etc. But dynamics, it is a branch of mechanics which is concerned about the causes, that is, the force and torque, that cause motion of the bodies. So we are not interested in dynamics. In this video, we will go through kinematics. Kinematics is derived from a Greek word that means motion. First, we go to the concept of a point object, point mass, or a particle. When to get a point object? When the size of the object is very much less in comparison to the distance covered by the object, then the object is considered as a point object. For example, here we can see that the car is very small as compared to the distance covered. So that means here we have to consider the car as a point mass or a point particle or a point object. So let us name a point A and then we can determine the motion of the car. Dimension of the car are small as compared to the distance traveled, so we can take it as a point object here. Now let us go through some of the definition. A body, a certain amount of matter limited in all direction and consequently having a finite size, shape, occupying some definite shape called the body. For example, we can consider a cone, we can consider a solid sphere ball, we can consider a cylinder, etc. They have a definite shape, size, and they occupy some definite space. The rigid body. A body is said to be rigid. It may be not perfect as a body as previously discussed. So rigid body may be a deformed one. That means this kind of body can be considered as a rigid one. But we have to say that it must be between 2 points. If we take the point A and B, the distance between these 2 points should be same. So this kind of body is known as a rigid. Next, we go to the definition of a particle. The smallest part of the matter with zero dimension, which can be described by its mass and position defined as a particle. Thus, a particle has only a definite position, but no dimension. So we can say that particle is a dimensionless body. In the problems, when we go to the numericals, we are going to discuss, we will only consider a body to be particle for the sake of the simplicity. Next, what is motion and what is rest? A lot of persons confuse between the rest and the motion. An object is said to be in a rest if it does not change its position with respect to its surroundings with the passage of time. For example, if I consider an object, a pen on the table, and the pen is at the same position after 1 hour also. For example, I kept the pen on the table at 9 a.m. and at 10 a.m. I'm watching the pen is on its own position. That means the pen is not moving at all. That is, the pen is at a rest. But if I consider an object, or if I consider a little insect that is moving on a table and the passage of time after 1 hour it has moved from point A to point B, then we can say that insect is in motion. There are various other examples in our day-to-day life. Some of the examples of motions are, we can see some objects as rest and others in motion. Example, birds fly, fish swim, blood flows through the veins in the arteries, car move, etc. These are the For one of the examples of the motion, atoms, molecules, planets, stars, and galaxies are all in motion. We are very fond of the cartoon Tom and Jerry. So, Tom and Jerry is in left motion, and Tom and Jerry at the right is at rest. Now, the basic difference between rest and motion, we will give some of the example in the relative terms. Motion is a combined property of the object and observer. There is no meaning of rest or motion without an observer. For example, passengers in a moving bus, the roadside trees appear to be moving backwards. But for a person standing on the road, the sight perceives the bus along with the passengers as moving. So here it all depends on the passengers and the person standing on the road. So for the passenger, all the things are moving, but for a person standing on the roads, only the bus is moving. However, a passenger inside the bus sees his fellow passenger to be at rest. Similarly, a passenger who is sitting inside the bus, he will consider the other passengers as rest. There is nothing like absolute motion or absolute rest. In this whole universe, we know that the earth is rotating about its axis as well as it is revolving around the sun. The stationary objects like your classroom, a tree, a lamppost, etc., do not change their position with respect to each other. That is, they are at rest. Although the earth is in motion, but to an observer situated outside the earth, say in spaceship, our classroom, trees, etc., would appear to be in motion. But for us, when we are sitting in a classroom, for us it is all in rest. Therefore, all motions are relative. There is nothing like absolute motion or absolute rest. Now we go to the frame of reference. What is frame of reference? Here, there are two examples taken side by side. It is a system to which a set of coordinates are attached with the reference to which the observer describes an event. So here we have taken two examples. An observer who is sitting at the platform and an observer who is sitting on a train. For here, in these two cases, the frame of reference would be different. A passenger standing on the platform observed that a tree on the platform is at rest. So for this passenger, this tree would be at rest. But when the same passenger is passing way on the train, but if the same passenger is on the train, observe that a tree is in motion. But since the train is moving, so he will also observe that the tree is lagging behind. That means the tree is in motion. Observe that the tree is in motion. In both the conditions, the observer is right. When the observer is standing on the platform, his observation is also correct. The same observation of the same observer when he is standing on a train, for him also the observation is correct. So in both the cases, he is correct. Both observations are different because in the first situation, the observer stands on the platform, which is the reference of frame. So for his, the frame of reference is at rest. But when he is in a moving train, his frame of reference is also moving. So the frame of reference is in moving position. Similarly, we can also consider the frame of reference in case of a moving bus and passenger inside a moving bus, or also an observer who is standing on the road. For both of them, the frame of reference is different. Now, frame of reference is usually considered as an origin. So whenever we will consider the frame of reference, we have to remember that we have to take that point as an origin. Whether we take a three-dimensional coordinates or we take a two-dimensional coordinate, we have to remember that the point object should be always at the center, at the origin. So to locate the position of the object, we need a frame of reference. To give a specified position of the object, we need a frame of reference. A very convenient way to set up a frame of reference is to choose a three-dimension perpendicular axis. So rather than choosing a two-dimension, we can choose a three-dimension axis because it can give its all direction in three axes like Z, X and Y axis. The coordinates x, y, z of the particle then specify the position of the object with respect to that frame. So whenever the object moves from this position up to this position, here also we can consider the same axis or the same frame. If any one or more coordinates changes with time, then we can say that the object is moving with respect to its frame. Types of frame of reference. Now there are two types of frame of reference. First one is known as the inertial frame of reference. That is, when frame of reference observer is either at a rest or in a state of constant velocity. So whenever the observer is at a rest or in a state of constant velocity, then those type of frame of references are also known as the inertial frames. For example, for practical purposes, we can take an example. A frame of reference fixed to the earth can be considered as an inertial frame. Strictly speaking, such a frame of reference is not an inertial frame of reference because the motion of the earth around the sun is accelerated motion. So it's not in a constant velocity. But still, a person standing on earth, it can consider it as an inertial frame of reference. Now, the next topic is a non-inertial frame of reference. When frame of reference or observer in a state of accelerated motion. In the previous case, it was constant velocity, there was no acceleration. But here, we will consider the accelerated motion. Then those type of frame of references are known as the non-inertial frame of reference. Now, however, due to negligibility of small effects of rotation and orbital motion, the motion of the earth may be assumed to be uniform. Hence, a frame of reference fixed to it may be regarded as an inertial frame of reference. Now, discussing about the types of motion, there are generally three kinds of motion. First is one-dimensional motion, two-dimensional motion, and three-dimensional motion. Let us go through the differences. One-dimensional motion, motion of your body in a straight line. If we consider the motion of a car on a straight road, it can be considered a one-dimensional motion. So on a real axis on a straight line, it can be considered a one-dimensional motion. Two-dimensional motion, that means on a plane, on a 2D plane. So that would be considered as a two-dimensional motion. Example, motion of a car on a circular turn or motion of billboard's ball. Three-dimensional motion. Motion of a body in a space is called a three-dimensional motion. When we consider a three-dimensional motion, that means we have to consider a frame like this, that is x, y and z axis. When all three coordinates of the position of the body changes with time, then it is said to be moving three-dimensionally. That means moving of a flying kite or moving of flying insect can be considered as a three-dimensional motion. So here are some examples. Motion of a train along a straight track. It is a straight track. Similarly, motion of a freely falling body. It can be considered as a 1D motion. 2D motion, example like motion of the queen on the carrom board, an insect crawling on the floor of the room, motion of object in horizontal and vertical circle, etc. Motion in three-dimensional motion. These examples can be a bird flying in the sky, a random motion of gas molecules, the motion of an aeroplane in space. Now, we will go through the distance. What is distance? The length of the actual path traveled by the particle during the given time interval is called a distance. So distance may be either positive, negative or zero. This graph cannot be considered as a distance. This graph can be considered as a distant time graph. This graph, the previous graph, cannot be considered a distant time graph. Why? Because here the distance is decreasing. Distance can never be in a decreasing position. Here, yes, because distance is increasing. The graph shows an increasing. Yes, the distance can increase with time. Here also it cannot be considered as a distance because again it's decreasing. So a distance can never decrease. Distance may be either 0, positive, but it can never be negative. Now let us consider a very genuine case. Let this be point A and let this be point B. Suppose an insect has to travel from point A to B. It can go in this way or it can also go in this way. So the shortest path through which it has gone, that means a straight line, is displacement. But the curvy line through which it has gone, it may be considered as a distance. So here we can consider that displacement is the shortest path. It is the shortest path between A and B. That means the straight line is the shortest path between any two given points in the two dimension. Now, a very important things to be noted down. First, the distance is always greater than equals to displacement. Why we are asking about greater than equals to? For example, there are considering 2 points here. If a boy go from point A, or let us consider point particle. If point particle goes from A to B in a straight line, here the distance and the displacement are same. But we have to always remember that distance is always greater than displacement. Second point, for a moving particle, distance can never be negative, 0, but displacement can be 0 or can be negative. So ultimately we can say that distance is always greater than 0, but displacement can be greater than, equals to, or less than 0. That means negative. For the motion between 2 points, displacement is single valued where distance depends upon the actual path and also can have many values. So as I have said that the shortest distance between any 2 points is a straight line. So we can say that displacement between any 2 points is a single valued, but distance can be varied. It can also be go by this way or it can also be go by this way. So the distance can vary, but displacement never. For a moving particle, distance can never decrease with time while displacement can. Decrease in displacement with time means body is moving towards the initial position. So when we consider the displacement decreasing, that means a particle is going from A to B and again is coming back from B to A. So in this case, the displacement can be of the decreasing form. Now distance versus displacement. Distance is of length or path actually traveled by a body in any direction, and displacement is the shortest distance between the initial and the final position. Second, distance between two given points depends upon the path chosen. Displacement between 2 points is measured by the straight path between the points. Third, distance is always positive, but displacement may be positive as well as negative or even 0. Fourth, distance is scalar quantity, but displacement is a vector quantity. Distance will never decrease, displacement may decrease. I hope you all like this video. Thank you all. Please like, share and subscribe for the notification of new videos on JEE.